In this video, we will study the relationship between the functions sine and cosine and their graphs. But first, a little background information. You need to basically memorize what the parent function for the sine function and the cosine function looks like. Both functions have a period of 2 pi. So the length of one repetition is going to be 2 pi. The sine function starts at 0, and then it goes to its highest value, which will be at 1, and then it falls to the midline, and then it goes to its lowest value, and then back to the midline. So the sine function looks like this, and you should really just memorize that this is what the sine function looks like. All right, it starts from 0 and goes up first. Now the cosine function starts at 1, and then it falls to the midline, and then it goes to its lowest point at -1, returns to the midline, and then ends at its highest point. So this is what the parent function looks like for the cosine. All right, so memorize that the sine function looks like this, cosine function looks like this. Notice that the amplitude is 1. It goes up to 1 and down to -1 for both, and the period for both is 2 pi, the length of one repetition. So the first part of this exercise is we need to do matching between the graphs and these functions. So problem number 1 is just the parent function of the sine function. So we saw that the sine function starts at 0 and it goes up and down. So it kind of looks like this. The only difference is if you look really closely, here it looks like the period is pi when it should be 2 pi. So I have to keep looking. Okay, this one has a period of 2 pi. It's a little bit hard to see, but it's upside down. The sine function should go upward first. This one has a period of 2 pi and it goes upward first, but it has an amplitude of 2. It goes too high. So the answer is this one. This one has a period of 2 pi and it goes up and down, and the amplitude is 1. So the answer to problem number 1 is function g. Okay, so I'm just going to check these off one by one as we do them. So that one is done. Maybe I'll circle it. Okay, so g is done. Now let's look for cosine, the parent function for cosine. So here it is right away. The parent function for cosine is a. Notice it starts high and then goes low. The period is 2 pi, the amplitude is 1, so a is looking good. What about number 3? Now, if you have a negative sign in front like this, that is going to be a reflection over the x-axis. So we're looking for the graph that looks like this, except it's upside down. So it should go down first. And that's what's happening here at E. Okay, it has a period of 2 pi, an amplitude of 1, but it goes down first. So it's upside down, so that's why the answer is E. So for number 4, we need the cosine function that is upside down. So that's going to be right here at D. All right, notice it has the correct period of 2 pi, and it has the correct amplitude, but the cosine function usually starts off high, but this starts off low and goes up. So it's upside down. Okay, now number 5, y equals sine of 2x. So that should just be like a normal sine function, like g, except for, actually, you know what, let me be careful. This 2, let me go back to my other screen. Consider the difference between y is equal to sine 2x, and compare that with y is equal to 2 sine x. Okay, now this 2 that's in the very front tells you the amplitude. All right, so that would affect how tall the graph is. This 2 does not affect the amplitude. All right, this was an A value, by the way. This 2 is a B value, and it affects the period. So the period is always 2 pi divided by the B value. So in this case, that would mean 2 pi divided by 2, which means that the period would equal pi. So looking at this problem, this 2 is a B value, like I was just discussing. So it's not going to affect the amplitude, it's going to affect the period, which should be pi. So we are looking for the graph that has the shape of a sine function, but the period should be pi. So there's a period of 2 pi, that's a cosine function, that's a cosine function. Oh, here we go, function B. All right, it looks like a normal sine function except for the period is pi. Now number 6, cosine of 2x. So again, the period should be pi for the same reason. So we're looking for a regular cosine function. So here's a cosine function, but this period is still 2 pi, so that's not it. This is a cosine function, but the amplitude has changed, so that's not it. That's a sine function. Oh, here we go. H. The answer here should be H. This is a normal cosine function with an amplitude of 1, and it's the right side up, but the period is pi like we wanted. Now for number 7, this 2 is an A value. That's going to affect the amplitude. So I'm looking for a sine function that goes up to 2 and down to -2. So let's see, that is a cosine function. In fact, we already did this one. This is a sine function, but the period, we already did that one. Okay, look at F. This is a sine function where the amplitude is 2. So it goes up to 2 and down to -2. So the answer to this one is F. And for number 8, we need a cosine function with amplitude of 2, because this is an A value. And that's what we have left for C. Function C is a cosine shape. It has a normal period of 2 pi, but the amplitude is 2. It goes up to 2 and down to -2. So that's it for the matching.